Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zul Halim. Today I will for my oral presentation. The title for my presentation is Variable Rate Technology. Okay, for my table of content, there is six. First is introduction, description, explanation, elaboration, conclusion, and last is reference. Okay, for my introduction, precision farming is a new method of managing farms and a strategy that uses exact location-specific information to manage inputs for farm productivity. Precision agriculture and farming go with each other. Precision farming involves making the most use of every available space on the farm and caring for it as it requires. Notably, this could be only accomplished if the specific soil and crop traits for each area of the field are known, when applied, where and when necessary. Farm production inputs including pesticides, herbicides, seeds, fertilizer, and water will be used most effectively. That means reaching sustainability. Simply said, this management strategy concentrates on doing the right thing at the right moment. For my description, a guidance system like AutoSteer can be created using the GPS. Using a mix of real-time kinematic or RTK, correction of GPS signals, software and hardware that allow the input of control maps, and mechanical equipment to steer tractors. AutoSteers control the steering of agricultural equipment. Okay, as we can see, this is like bar guidance system that was installed on the tractor or agricultural equipment cab and gives the driver guidance by way of a horizontal light display. This works well for spreading or spraying operation despite being less precise and less expensive than auto steer. Okay, for my explanation, the Differential Global Positioning System (DGPS), microprocessor, microcontroller, DC motor, 12-volt battery, threaded screw arrangement, and fluted roller granular fertilizer applicator were all components of the tractor-mounted VRFA system. The approach was based on a computerized data file called a prescription map of soil nitrogen, which contain precise information about latitude and longitude as well as input rates that needed to be used. Okay, as we can see here, this is the longitude and latitude. The evaluation of soil nutrient variability and its mapping is the initial stage in the creation of the VRFA system. Using a systematic grid sampling method, the field was split into equal sections of 30 meter by 30 meter. A total of 10 soil samples were collected in an area of 0.85 hectare at a depth of 150 millimeter. Georeference using a GPS device, Garmin Oregon 450, and then evaluated for soil status in the lab. Using the IDW interpolation technique, the nutrient levels at various fields intermediate locations were calculated in MATLAB. An IDW interpolation algorithm was created to determine the nutrient level at various intermediate locations. Using MATLAB build code, a digital soil nutrient availability map was created with the matching coordinates of the chosen field. For my elaboration, I have put a picture, and the VRFA system flow diagram is seen above. Using the Visual Studio platform, the constructed VRFA system was synced with the GPS microprocessor, microcontroller, actuator, and metering mechanism. As we can see here, the GPS module GUI, the display is latitude, longitude, and fertilizer application rate. And for the microcontroller, if you can see here, calculation of required exposure length and calculation of current exposure length. Okay, this is the second picture, process flow diagram of VRFA system with different components. For my conclusion, in conclusion, it is essential to protect soil health and supply crops with the appropriate nutrients in order to produce the best yield possible. It is crucial to avoid applying excessive amount of fertilizer, since inefficient fertilizer application lowers the effectiveness of plant nutrient uptake and raises total production expenses. This is my reference. That's all for me. Thank you.